What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we'll be talking about tree diagrams, which is your 9.4 part 2. So just make sure that you've got your notes ready. And what we'll be able to do today is determine what a tree diagram is, how it's used, construct it, and then be able to use those tree diagrams to determine probabilities. Two things we want to make sure we are aware of before we start. Conditional probability is the probability of something happening given that something else happened. It kind of goes along the lines of dependent events, so it's very closely related. But conditional just means something needs to happen first, then the other thing can happen. So it's almost like a domino effect. And a tree diagram is a way to organize and display those conditional probabilities. An example of conditional probabilities is this. There are 8 black socks and 8 white socks in a drawer. You draw one sock and then the second sock without replacement. Make a tree diagram first to represent the situation. So the first thing we're going to do is decide. When we first decide to draw a sock, we can either choose a black one or a white one, right? From here, after this, we can then choose, if we decide to draw if we drew the black sock first, we can go from there again and draw another either black or white sock. Or if we drew the white sock first, we can do black sock second or white sock. Typically, we would want them to match, so we'd either hopefully choose a black and a black sock or a white and a white, but sometimes mistakes happen. So here you're seeing some differences. When you choose to take that black sock first, that is 8 out of 16. And then the white sock could also be an 8 out of 16 probability, okay? But if you chose the white sock, let's keep going here. Let's say we chose another white sock, that'd be 7 out of 15, but a black sock would be 8 out of 15 still. Do you see that? Because there would still be 8 options to choose from. Or if we chose a black sock first, that means the leftover amounts would be 7 out of 15. But if we chose a black sock first and then a white sock, that would be 8 out of 15. Okay? So there's a total of 16 socks. Probably should have started with that. Okay? Now, once we figure out our probabilities here, then we'll be able to use our conditional. So it starts off with conditional and then finishes out with and, because I want a black and another black, or a black and a white sock. So now we're going to take the probabilities and put these together. Okay? So if I wanted 2 black socks would have to be a black and a black. So it'd be 8/16 and 7/15. Right? Which would essentially mean we've got to multiply some things here. Okay? So 8 times 7 is 56, and 16 times 15 is 240. But then these can both be reduced. So 56, let's just do by 4, we get 14, and 240 by 4, we get 60. Can reduce again, maybe by 2s, 7 out of 30. Okay, so the probability of 2 black socks would be 7/30. How about a black and a white sock? Well, let's look here. Black and white. Black was 8/16, white was 8/15. So black and a sock and then a white sock. So 8/16. Or sorry, white then given black. I'm going out of order here. So that one would be white and then black. So white when given black is, I've already got black, but now I'm getting actually a white. That'd be 8 out of 15. So no other technical calculations needed. 2 white socks, that would be 8/16 times 7/15, which we already did, gives us 7/30. And then black if I'm given white. So if I'm given white, the probability for black would be 8 out of 15. Okay, so the whole thing is just to be able to read and discuss what our probabilities are being shown. Next up, a class contains 14 girls and 11 boys. 2 students are selected to pass things out. So very similar to what we did with black and white socks, make a tree diagram to represent. The first thing we want to make sure of is we need to know our total, which is 14 girls plus 11 boys. So that's going to be 25 students. Okay, so we break it up into 2 sections at first. The first choice you can have is a girl or a boy. If you choose girl, that is 14 out of 25, and if you choose boy, that is 11 out of 25. From the first pick, now we can do what happens when I pick next. Again, I can choose another girl, which would then only be 13 out of 24, or I can choose a boy, which would still be that 11 count out of 24, right? If I chose boy first, I would still be able to choose 14 girls from that list out of 24 students now, but if I chose boy first then boy second, that's only 10 boys left out of 24 students, okay? So now we're going to do some calculations. 2 girls. Girl number 1, 14 out of 25. Girl number 2, 13 out of 24. So I would be doing 14 out of 25 times 13 out of 24. Right away, since I don't want to have to deal with big numbers, I'm going to go and try to cross cancel this 14 and 24. They both can be divided by 2, so 7 and 12. So that's going to be a little bit easier. 7 times 13 is 91, and 25 times 12 is 300, and I can't simplify that anymore. Okay? What would be my probability of a girl given a boy? So if I start with boy, and I want my probability of girl, forgot to label these, girl, boy. My girl's probability given boy is 14 out of 24, which I can reduce that by 7/12. Probability of 2 boys, 11 25ths, 10 24ths. So 11 25ths times 10 24ths. Again, I'm going to cross cancel here because I have big numbers I don't want to deal with. If I both divide 10 by 5, I get 2. 25 by 5, I get 5. So 22 over 2 boys, 5 times 24. 5 times 24 is 120, and I could simplify this even more. 22 cut in half is 11, and 120 cut in half is 60. So 11 60ths for 2 boys. And then what's my probability of boy given girl? If I choose girl first, boy next would be 11 over 24. No simplifying there. And then the second is a boy. The second is a boy just means I have 77 out of 300 for my first choice of boy then girl, but then my second has to be a boy. I would need to add those 2 things together. Okay, so second being a boy can only happen if you discuss the probabilities of both things happening. So 77 out of 300 is boy then girl, but my second would be 55 out of 300. This is boy then boy, or 132 out of 300. And that just reduces to 11 over 25. Okay? So the second has to be a boy, choosing both of those. Or the second is a girl. This one kind of fell off of the page here. Second is a girl. If I do girl, girl, that's 91 over 300. But if I do girl, boy, that's 77 over 300. So I just have to add those probabilities together to see how often that would be happening. That'll be 168 over 300, or simplified down, 14 over 25. Okay? You flip a coin 3 times. Now we're going to do 3 levels of tree diagrams. Draw a tree diagram to represent the situation. So when you flip a coin, you can land on heads or tails. This is one flip. Okay? Both of these are half probabilities. Then I flip it a second time to flip. From here, I can again get heads or tails. Both of these are 50-50 chance, or 1/2 chance. If I flip tails first, I can then do heads or tails from that, another 50-50 chance. Okay? And then if I flip it a third time, I either have heads, tails, you get the idea, 0.5, 0.5, or 1/2, heads, tails, 0.5, 0.5, heads, tails, 0.5, 0.5, heads, tails, 0.5, 0.5. Okay? So, now let's answer some questions. Heads, tails, heads. So I'm just going to follow my probability here. Heads, tails, heads is 0.5 times 0.5 times 0.5. So 0.5 for heads, 0.5 for tails, 0.5 for another head, 0.125. For those of you who are doing some fractions, you'd get 1/8. Okay? The probability of landing on 2 tails and 1 head. So right here I'm just looking at how often can that happen. So I have heads, tails, tails. Didn't say what order. And tails, tails, heads. And I could also do tails, heads, tails. Okay, so each one of these is 0.125 probabilities, just like I did before. So multiplying those by 3, 0.125 times 3, I'm getting 0.375. Okay, tails, tails, tails. That is 0.125 because it's half for tails, half for tails, half for tails. Okay. And then probability of landing on 2 heads and landing on 1 tail. So you can do heads, heads, tails. You can do heads, tails, heads, or you can do tails, heads, heads. Okay? So each of these again is 0.125. So you're just adding those probabilities together or multiplying by 3. So 375. Okay? One day, there's a 40% chance of snow. If it does snow, then it's a 15% chance that school will be canceled. Show a tree diagram to represent the situation. Okay? So, first 2 options. Either there's going to be snow or no snow. So if I have snow, which is 40% chance, I'm going to write this as a decimal, 0.40, which means no snow is 60% chance, or 0.60. Okay? Now, if it does snow, there's a 15% of chance that school will be canceled. So no school, which is 0.15, which means if it does snow, there's an 85% chance that there is school. Okay? Now, if there's no snow, you're going to have school. And that is 100% chance. Whereas no school, we're just going to go and say 0. Okay? All right. If it snows, no school, I'm going to do 0.4 times 0.15. So that is a 0.06 probability. Okay? If it snows and we do have school, that is 0.4 times 0.85, which is about a 34% chance, or 0.34. No snow times school is a 0.6 times 1, so that's 0.6 chance. And no snow, no school, that's a 0% chance of happening. Okay? So, probability that there would be a snow day, well, we already calculated it. No school would be 0.06 for snow. Snow day given snow. Snow day given snow just means if I'm given snow and I have a snow day, which means no school, that's 0.15 chance. Okay? This should say no snow day. Probability of no snow day, which means I'm going to have school, or there's school with snow or school without snow. So that's 0.34 and 0.6, which would be about 0.94, which is not looking good for a no school. Snow day given no snow. No snow, no school. This is snow day. That is 0 probability. Okay? So the tricky thing is just setting up your tree diagram, but once you set it up, you should be able to calculate some probabilities a little bit easier than that. Hopefully this video helped you. If it did, give it a thumbs up and tune in next time when we do our last quiz review of the year for Math 8. Have a great day.